This is multiplying polynomial expressions. It goes with your textbook. 18.2 is the section that you would look up and get more information on it. Your essential question: how do you multiply binomials? Remember, a binomial has two terms, and polynomials. And a polynomial can be a monomial, a binomial, trinomial. It can have any number of terms. Learning goal today is I can explain how to multiply polynomials. So I'm going to show you a video clip as a review. 2x with the quantity of x minus 3. So we'll use this. We're going to represent the first factor of 2x along the left side. So I need 2 x's. And I can click on this and extend this out so it's larger. Then represent x minus 3 along the top. And again, extend this out so it fits. We're going to fill in with tiles that have the same height as on the left and the same width as on the top. So right here, for x times x, we get x squared. For x times x, we get x squared. For x times -1, we get negative x. And that repeats. And for here, x and -1 will give me negative x. And that repeats. So inside here, these represent my solution. The first term is the two blue x squareds. So 2x to the second power plus we have 1, 2, 3, 4, 5, 6 minus x's. So plus, you can write it as negative 6x. You can also write your solution as 2x squared minus 6x. All right, so I was able to present it, and I'm pretty sure, yeah, so you guys have access to it too. And so someone wrote me in Go Guardian. Yes. So what I just did right now, and now let me get back to the right presentation tab. So when you guys are in your own Pear Deck, you can click on that video and watch it. You can watch it again. But now we're going to look at this here. So we have a binomial and a binomial being multiplied together. The rules are exactly the same. So the first factor goes on the left side of the grid and the second factor on the top. And we fill in the grid with tiles that have the same height as the tiles on the left and the same length as the tiles on the top. If you follow the key right here, okay, the product of two tiles of the same color is positive. Okay, the product of two tiles of different colors is negative. Right? And you can also rotate the x and negative x tiles by clicking on the black dot and dragging it. So what we're going to do is model this problem with the Mathagon PolyPad. I'm going to show you how to do that, and you can do that at the same time and kind of try it out and see how it works. All right. So some of you are in the Meet, some of you are in the Pear Deck. That's fine. You could be in either one. Okay. So when we do multiplication, that's when you're going to grab this shape here. Okay, and you can resize that by clicking on it and dragging either side up or down. Okay, but we want to model x plus 1, okay, on the left, and then x minus 2 on the top. So x is this one, and then plus 1 is this one, So that's x plus 1. That's the first polynomial, x plus 1. And then the second polynomial, x minus 2, that's going to go across here. So we're going to put an x, and this is where you'll just grab this and turn it to get to fit, and then minus 2. So that's minus 1, minus 2. Okay, and you can resize this by grabbing it if you wanted to make it so it goes and covers the whole area like that. Okay, so far this is what we have. This is just representing this problem right here of x plus 1, that's what we have on the left, times x minus 2, and that's what we have across the top. Right, so that's what we're showing right here. And now we're just going to fill this in. So I need to put a tile here that has the same height as this one and the same length as this one. So because they are both positive, or because they're the same color, my answer will be positive. So I don't want to use the negative x squared, I want to use the positive x squared. X times x is x squared, because this tile matches. It has the same height here and the same width here. These two x's are the same color, which tells me that my tile that I put here should be the positive version. All right, and then next tile. So we want to have one that has this height to match along the left, but also this width here. And this is green and this is red. These are opposite colors, which means I'm going to have a negative. And this repeats again. So positive x, negative 1 is negative x. And now we're going to move to the second row down here. So this tile and this tile, I want to have this height, but this width, that's going to be one of these because this is, well, they're not the same color, but they're both positive. So that's a little bit confusing. But this is positive because it's positive 1 times positive x. So this is positive x. So I think these rules here come from the textbook, where they're just using shades of gray for all of these, whereas these tiles here are more colorful. So this is cut right out of your textbook. So if you look at the examples in the textbook, you're going to see that this makes more sense. Whereas for this website here for Mathagon's Polypad, they won't necessarily always be the same color if they're the same sign. So positive 1, positive x. And then moving on here, positive 1, negative 1, those are opposite colors and opposite signs. So when you have opposite signs, you get a negative. And the tiles have to fit so that they have the same height and the same width. So this is a very visual way to do this. We're going to look at some other methods to solve this multiplication problem. But, you know, just from this now, if you have any zero pairs, you would then go ahead and cancel those out. Okay, and well, we do. We have this x and this x. Those are a zero pair. I would have to turn them. They do disappear. So what I have left after I move all my zero pairs is the solution that I need. And so we can write that as have 1x squared. I have 1 negative x. And I have 2 negative 1s, so that's negative 2. So this is the product of this multiplication. This is what we get as the product. And this is how you can do this with algebra tiles. But this is not the only way to solve these kinds of problems. We're going to look at some different ways to solve them as well. So we're going to go ahead and move forward to our next method. And so this should be a little bit familiar. It's the distributive property. We can use the distributive property to multiply two binomials. And so basically, the way we do that is, you can see we have an example here, x plus 5 and x plus 2. Those are both binomials. And so what we're doing is kind of taking one of the binomials and distributing it into the other binomial. So it becomes x times x plus 2 and 5 times x plus 2. And then from here, you can distribute the way you would normally distribute, where you have a factor on the outside, you can bring it in and multiply with each term on the inside of the parentheses. You do that twice. And then you have all these terms listed out. You want to simplify those, and then you would combine any like terms. Like terms in polynomials have to have the same variable and the same power on the variable. So here I have an x squared term, an x term, an x term, and a constant. So only 2x and 5x are able to be combined, and that would give me 7x. So this is our second way of multiplying binomials. Again, you can use any of the methods. You can use algebra tiles, you can use this method, or even the next method I'm going to show you. But let's go ahead and do this example here. So here is where you do want to follow along with your pear deck. And basically it's coming from right here. This 4 is going to go here. And then our next step is to distribute. Okay, so 2x times x, and then 2x plus 3. And then again, this is 4. Okay, that's just being carried down, and I'm going to multiply together. So go ahead and try to fill in this next row here. What would be in these next 3 boxes? It's going to come from multiplying 2x and 3. That's what would be in this box here. What's going to go there? 2x times 3. How much is 2x times 3? Remember, you can change the size of your pencil tool by clicking on the sizer and making it smaller. So go ahead and go to your Pear Deck tab and start writing and filling in these boxes. So 2x multiplied by 3 I don't see the correct answer just yet. Here's one, 2x. So right here, we're going to put 2x, okay, because they already have the times 3 written out. And then what's going to go in these boxes? What am I multiplying with x? What am I multiplying with 3? So 4 and 4 is what we'll put there. Put a 4 here, and put a 4 here. And then we're going to simplify this out. 2x times x, right? So 2x squared, because x times x is x squared. And then 2 times x times 3. Well, the 2 and the 3 multiply together to give you 6. And then 4 times x is just 4x. And 4 times 3 is 12. Okay. And if you're looking for like terms that you can combine, you have to have the same power and the same variable. So there's 2 like terms here that I can combine, which are going to be these 2 terms. And so when I write my final answer in, we have 2x squared, 6x plus 4x gives us 10x, and then plus 12. Okay, I can't combine anything else together because I've combined all the like terms that I possibly can. All right, so any questions on that method? Because I'm going to show you the last method, which I like probably the best. It's called the FOIL method. Just remember the word FOIL, F-O-I-L, and then it tells you how to multiply a binomial. And I still use the FOIL method. That's something that it's easier to remember because it has a little mnemonic to go with it. So let me go ahead and move you guys forward. Okay, so we're going to look at this last method called the FOIL method. And there's a couple diagrams here for you. And so it's called FOIL because F stands for first, O stands for outer, I stands for inner, and L stands for last. And you got some diagrams here. So like first, you take the first term, so 2x and 4x are your first terms. Then outer, so 2x and 5 are -5. And then inner, so the innermost ones, 3 and 4x. And then L for last, so 2x, I'm sorry, so 3 and -5. And then you write out those products, you'll get 4 products. And then you simplify by, typically it's the middle 2 terms that would combine, not always, but typically that's how that works. So you can see it with the arrows. Again, this is showing FOIL. Also, first is the red, outside for O is the blue, inside for the yellow, and then last, we're using purple to show it's the last terms of each binomial. And that's what they're showing here in these examples here. So if we want to use the FOIL method for 3x squared minus 2x times x plus 5, you would use the FOIL method. And so they list out the letters for you. So multiply the first terms and you would get, what would you get? First terms, they have an arrow pointing to them here. So 3x squared times x. Well, you can multiply. You got to remember also using your exponent rules, okay? So 3x squared times another copy of x gives us 3x to the third power. So that would be what we get here. They're not real consistent on their colorings here, but maybe I'll just go with the first coloring. Okay, so here is where we're going to do the first terms. So that's 3x squared and x, and that gives us 3x cubed. And then O is for outside or outer. However you want to think of that. So that's the most outside term all the way on the left and all the way on the right, which is 3x squared times x. So we can multiply 3 and 5 together to get 15. And then we have x squared. All right, and then moving on, we're going to do inner next. I'm going to go with this color scheme here, inside. So inside is the innermost 2 that you can see, right? Those are the guys who got to multiply next. -2x and x. So -2, and then x times x is x squared. And then the last ones are the last terms. So the last of the first polynomial and the last of the second polynomial, -2x times 5, -2 and 5 multiplied together is -10. and then x. So if you look at these different terms that we've got using the FOIL method, there's two that are like. It's the blue and the green one, because they both have an x squared term. So I can actually combine these like terms, 15x squared minus 2x squared. That's going to give me 13x squared. And then 3x cubed plus 13x squared minus 10x. And that's how you do these ones. So there is one more slide where you can use any method you want to use. Okay, I'm going to put you on to student pace mode right now. And then what you're going to do is try these last problems, okay? You can use FOIL. You can use algebra tiles. You can use the distributive method. It's up to you which method you can choose to use. That's your choice. X and X, wrong color. There we go. So the first two terms, we get x squared. For the outside terms, we get negative 2x. For the inside terms, it's 1 and x. And for the last terms, we get 1 and negative 2. So that would give me negative 2. Now, of these terms, the only ones that are the like terms are these ones, okay? And so when I write my answer out, then what I'm going to get is x squared. Negative 2x plus x is negative x minus 2. And we did see that earlier. We got the same answer for the problem where we use the algebra tiles. All right. And so that's how you can do that one. That's one method, but whichever method you use, you should end up with the same answer. If you want to use the distributive property, I can show you that with this one. So basically, you're going to take this entire thing and you're going to multiply it with that, and then you're going to multiply it with that. And so we end up with x squared times x plus 6 plus 3 times x plus 6. So this is a different method of getting the same answer. And then from here, you're going to distribute in. So x squared times x is x cubed plus 6x squared. And then we're going to distribute here. 3 times x is 3x. 3 times 6 is 18. And then we're going to combine our like terms, which doesn't look like we have any, okay, because they all have different powers on the variable. So all we're going to do is just rewrite it in standard form. So the x to the third power goes first, and then 6x squared plus 3x, which is already in standard form. And the way you do that is you just want these powers on the x's to be decreasing. So this was our answer for the first one. This is our answer for the second one. And that's the end of this lesson. So I'll have to